Welcome to the Deep Dive. We dig into the latest concepts, the newest research to bring you, well, the stuff that could really change things. Today, we're looking at something that might just transform how you perceive everything. I mean, imagine having vision that lets you see invisible light, or look through certain walls, or zoom in like a telescope. It sounds like pure sci fi, right? But it's the actual goal of a startup called Super High Glasses, or SHG for short. Now, most smart glasses out there today, they often need your phone, and what they can do feels a bit limited. So our mission here is to unpack how SHG plans to, frankly, blow past those limitations. They're aiming for features that, feel like they belong in movies, using some seriously advanced tech to redefine human sight.
And that's the key, isn't it? Redefining sight. SHG isn't just pitching another gadget. They're trying to pull together some real cutting edge stuff. We're talking 6G terahertz waves, brand new kinds of analog electronics, advanced materials like graphene, maybe even computing inspired by biology. So yeah, it's not just an accessory. They see it as a fundamental extension of your senses, literally changing how you see the world.
Okay, so that's the big picture. But what can these things actually do? What are the superpowers, so to speak? The sources say they want them to look just like regular glasses, which is interesting itself. No big clunky headset. But the real magic is in three core capabilities. Oh, and they're aiming for this semi-passive power system too, drawing energy from the network from the environment. Pretty ambitious. So first up, multi-spectrum vision. This means seeing light outside our normal range, like ultraviolet, UV, and infrared IR. The real insight here isn't just seeing invisible stuff, it's that suddenly everything around you provides way more information. Like the environment becomes this data stream you can read.
Exactly. And the tech behind that is fascinating. They're talking about sensors, maybe graphene based, maybe other nanomaterials built right into the lenses or the frame, super sensitive to UV and IR. Then you need to process that. So ultra efficient analog electronics would basically translate that invisible information into something you can see, overlaying it on this augmented reality display in the lenses.
And the sources give this really cool example. A biologist, Luca, using these glasses, he could apparently track invisible pheromone trails left by wasps. He described it like the forest lit up with invisible highways, seeing their routes, chemical signals from other insects. Amazing.
Yeah, that's a great illustration.
And it's not just for scientists. Think about detecting UV hazards you can't normally see, or much better night vision for security, or even new ways to analyze things in medicine.
Definitely broad applications there.
Okay, so seeing invisible light is one thing, but then there's semi-transparent vision. This uses terahertz waves, T-hertz waves. The idea here is you could perceive objects hidden behind things like clothes, plastic, maybe even some types of drywall. It's about seeing through stuff.
Which of course makes you ask, how? How does that work? Well, it involves tiny transmitters and receivers, again, possibly graphene or similar resonant structures, built into the glasses. They'd send out and pick up these T-hertz waves, which can pass through certain materials. Then, specialized analog processing, maybe using that bio-inspired computing for efficiency, reconstructs an image of what's behind the barrier.
Let's go back to Luca. He used this feature in dense fog. Apparently, the fog looked less dense to him. He could see the shapes of trees, the ground with a sort of thermal halo. He could move around easily while others couldn't.
That's a powerful example of overcoming visual obstacles.
And get this. He found a hidden bird's nest inside a really thick, thorny hedge. The glasses made the hedge seem semi-transparent, and he could see the faint heat signature of the nest and eggs inside. Didn't even have to disturb it. Wow.
So you can see the potential, right? Security checking for hidden items, plumbers finding pipes without smashing walls, navigating in smoke.
Absolutely. It's information access beyond physical barriers.
And the third pillar is amplified and dynamic vision. Basically, telescope-like zoom and seeing incredibly well in low light, much better than current night vision.
Right. This relies on things like dynamic micro-lens systems in the optics, very low noise sensors, graphene pops up again here potentially, and AI-driven analog image processing. The key is doing this amplification in real time, with almost zero noticeable delay. So what you see feels immediate, natural.
Luca's experiences here sound incredible too. Exploring a pitch-dark forest at night. Through the glasses' IR vision, the forest apparently turned into this ethereal green world. He could see deer moving, foxes sneaking around, all showing up as luminous shapes.
Giving you senses you just don't normally have.
And the zoom. He zoomed in on an owl way off in the distance, said he could see every single feather, its eyes glowing green. It wasn't just looking at it, it felt like he was right there. That sense of presence, yeah.
But the example that really blew my mind was him looking at the Orion Nebula. He saw it in amazing detail. And it wasn't just a static picture. There was an AI animation overlaid showing the gas and dust clouds swirling, condensing. It even pointed out little bright spots, labeling them protostars or new stars being born.
It's incredible.
So it's not just seeing better, is it? It's like the glasses are interpreting the universe for you, blurring the lines between just looking and actually deeply understanding, moving from sight to insight almost.
That's a really good way to put it. And achieving all this.
Yeah.
Well, it takes some seriously groundbreaking engineering working together. It's not just bolting parts together. One of the most revolutionary parts is how they plan to power these things. It's called the Wireless Power 6G terahertz and rectifierless architecture. The big idea: get rid of traditional batteries, or mostly get rid of them. The glasses would actually harvest energy directly from 6G radio waves in that terahertz band, maybe even from a dedicated frequency just for power.
Wait, really? Harvesting power from the air?
Essentially, yes. Uses extremely efficient analog electronics and this rectifierless approach. Now, normally, converting radio waves, which are AC, to the DC power electronics, involves a rectifier. And that step wastes a lot of energy. SHG's design aims to bypass or minimize that loss, making the power conversion much, much more efficient. They're looking at invisible graphene rectennas built into the lenses to capture this energy. The goal is tens, maybe hundreds of milliwatts continuously.
Okay, let's break that down. What kind of numbers are we talking about? How much power do they need?
The target they mentioned is around 100 milliwatts of continuous power for the glasses to operate fully.
And the frequency? You mentioned 6G.
Right. The research seems to be focusing on the 150 to 300 gigahertz range. It's kind of a sweet spot, balancing how well the waves can penetrate materials versus keeping the antenna size small enough for glasses.
Okay, 100 milliwatts. But what about efficiency? Getting power out of radio waves isn't easy, is it?
Historically, no. Tiert's Rec 10 efficiency has been really low, like under 1%. But there's been progress. SHG is aiming high, like 30% to 50% efficiency for their prototypes, and maybe even 60% to 80% eventually for commercial versions, thanks to graphene and that clever analog design.
So, if they need 100 milliwatts in the glasses, and let's say they hit 50% efficiency,
then they'd need to receive about 200 milliwatts of radio wave power from the 6G network hitting the glasses.
Okay, 200 milliwatts hitting the glasses. That sounds significant. Which brings up the big question. Safety. How do you beam that much power, especially at those frequencies, near someone's head without exceeding safety limits? Because the number you calculated, that 200 watts per square meter power density on the glasses, that's way higher than the current public limit, which is around 10 watts per square meter, up to 300 gigahertz.
That's absolutely the critical challenge they have to solve. And their solution is pretty clever, multi-layered, really. First, the 6G network wouldn't just be spraying energy everywhere. It would use what's called ultra-narrow and dynamic beam forming. Think of it like a laser pointer for energy. The beam would be tightly focused, precisely tracking the glasses. So that high 200 William Bernard density would only be on the small area of the glasses themselves. The surrounding area, the user's body, would get much, much less, staying well within those safety guidelines.
Oh, okay, so it's targeted.
Highly targeted. Plus, they talk about energy on demand, sending power only when needed, maybe in quick bursts or just a precise trickle, not constant high power. And there's also the physics of T-Hertz waves themselves. They get absorbed very strongly by water and tissues, so they don't penetrate deep into the body, maybe only half a millimeter into the skin. That reduces the risk of internal heating or damage compared to lower frequencies, even if the localized density on the glasses is higher.
So it's a combination of precise targeting, sending power only when needed, and the inherent properties of T-Hertz waves. Smart, not just brute force power.
Exactly. It's all about maximizing efficiency at every step, from the beam forming to the rectifierless harvesting to the electronics inside the glasses, squeezing value from every bit of energy.
Which brings us to the electronics themselves.
Right. Next generation analog electronics and bio-inspired computing are key. Processing signals directly in the analog domain, especially at these high frequencies, uses dramatically less power than converting everything to digital first. This needs new kinds of transistors, probably using graphene or other 2D materials that work efficiently way up in the decahertz range. And then there's the really forward-looking part, exploring bio-inspired computing, trying to mimic how incredibly efficient biological systems like our brains process information in parallel. That can be crucial for handling the complex AI tasks these glasses need without draining the power budget.
It sounds like a massive undertaking on the engineering side. So who's the target audience for this initially? Who are they building these super high glasses for?
Well, realistically, the first users will likely be early adopters, especially professionals who can really benefit from these advanced visual powers.
Like who?
Think maintenance techs who need to see wiring in walls, or first responders needing to see through smoke, law enforcement, maybe even serious amateur astronomers or researchers. People whose jobs or passions push the limits of normal vision.
Makes sense. Start with those who have a critical need.
Exactly. But the long term vision, if they can pull it off, is much bigger. They see SHG potentially becoming a mass market device, maybe even down the line, replacing smartphones as our primary interface with the digital world, offering a more natural UI and this radically expanded perception. Once they miniaturize it and get the cost down, of course.
And how would they make money? Selling the glasses.
Primarily direct sales, yes. But they also mentioned possibly having premium subscription tiers for certain advanced AI features like the nebula interpretation or access to specialized visual databases.
And the team. Who's behind this?
It's described as a mix of experts. TRS engineers, nanomaterial specialists, people who know low power electronics inside and out, AI architects, a multidisciplinary team. And right now, they're likely looking for seed funding to build working prototypes, test them in controlled settings, and probably build partnerships with big players in 6G and material science.
So wrapping this up, this deep dive really shows that super high glasses isn't just, another wearable gadget. It's a seriously ambitious vision. It's rooted in some really frontier science and engineering, trying to make science fiction abilities Superman vision part of our everyday experience. From seeing hidden trails in a forest to literally watching stars form, it's about revealing the unseen, bringing the universe closer.
Which really does lead you to wonder, doesn't it? What does it actually mean for us as people if our fundamental perception of reality gets amplified and changed so drastically?
Yeah, think about that for a moment. What could you find? What new things could you understand if your sight wasn't limited by your eyes anymore? It definitely makes you wonder.